Okay, more examples of applications of quadratics. These are a little easier because we don't have to come up with the equation. They're given to us, although the equations themselves, especially this first one, is quite large. Okay, so we've got a business that produces colored copies of a certain type of, and is trying to minimize the average cost per copy. Alright, so the average cost function in cents. Alright, was given by that equation with that really big number out front, x squared, the other fraction, 0.0145x, plus 60, where x is the total number of copies. Okay, find the vertex, determine the shape of the graph, find the minimum average cost per copy, which is what the equation gives us. It gives us the average cost, minimum average cost, it gives us the average cost per copy we want to minimize. And if it's a minimum, it should open up, and it does. The first number is a decimal, which means it's going to be a very fat function. It's a very small decimal, but it is a function that is opening up. And so it does have a minimum, right? So the shape of the graph, so A, the vertex, is the minimum because A is greater than 0, it opens up. Right, since it opens up, that vertex is a minimum. So we're going to find it. And so I'm going to find it by hand. You could find it on the calculator if you want to. You do have to adjust your window in order to find that. Right, but remember, it's just the opposite of B over 2A. The hardest part about this one is those numbers are just ugly. So it's the opposite of B. Well, B would be a negative 0.0145, so the opposite of that would be a positive 0.0145. And that whole thing divided by 2 times that really big number. Make sure I get all my zeros. 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6, 9, 3. And then it's just very carefully type that out in your calculator. Alright, and I'm going to round, since we're talking about copies, I'm going to round to the whole copy. So I'm going to round up to the whole copy. It comes out 7,795 and some decimals, so I'm going to round to 796 copies. Alright. And so that's my x value. Then the y value, which is the cost for that many copies, well, I plug 7796 in. And remember, it's the cost per copy in cents. And so it comes out to 3. When I carefully type that in, again, typing it in here. So make sure you're very careful with the decimals. It comes out to 3.5 cents per copy. So they're going to make 7,796 copies, and each of those copies are going to cost 3.5 cents. All right, and that's the minimum. The minimum per copy will be 3.5 cents per copy. And that's basically the answer. All right, that is the minimum. All right, the vertex. So part B, once I found the vertex, well, that found my minimum. Right, because it opens down, the minimum cost is 3.5 cents. I'm going to write out the word cents per copy. And they can copy, on average, 7,796. Alright, so the minimum cost is 3 cents per copy. When they do 3 cents per copy, they have to copy 7,796. Alright, and so A and B kind of answered themselves. Alright, we found the vertex, we determined the shape of the graph. From the shape of the graph, the minimum average cost had to be the vertex value. Right, that was the number of cost. So this would be the minimum cost. That would be how many they need to produce to get that minimum cost. Alright, the next example. Here's another, like the baseball example, but unlike the baseball example, this one they gave you the equation. Alright, but it is built off of that same equation we had before, where it would be that negative 16t squared plus our initial velocity times time plus our initial height. They just gave it to you. The initial velocity would be meaning this person's hitting the golf ball initially at a speed of 96 feet per second. The golf ball's sitting on the ground when they hit it. Alright, so the tee is close enough to the ground if it's on a tee. And so they're considering the height at that time 0. It's on the ground when it gets hit. So it is using that equation. We just already had it filled out for you. So there's the height of the golf ball, t seconds after it was hit. H represents the feet it is above the earth. So the first question is, find the height of the ball after the 4 seconds. Is the ball moving upward or downward at that moment? Alright, which actually, in order to do that, I'll probably have to figure out the vertex. Which side of the vertex is it on? Alright, so, the height of the ball after 4 seconds. Oh, I plug it into my 96 times 4 minus 16 times 4 squared. That comes out to 128 feet after 4 seconds. And then to figure out if it's moving up or it's moving down. Alright, there's 2 ways you can do that. You can look at the graph of the function, or you can determine the height of the ball. And so, since we did this last one by hand, I'll actually do this one on the graph. So I'm going to graph it and figure this out. I'm going to graph h of t. So I'm going to go to my graph. Oops, I keep hitting that instead of my graph. There we go. Alright, so I'm going to go here, clear out the graph I have in there, type in my 96x minus my 16x squared. The window I had before probably will work, because 96... I might have to go bigger. Alright, I'm just going to hit graph. Nope, it's off my page, so I have to go bigger. Alright, see, my graph's above, so that means I need to go to my window, and so there's quite a bit above. I might just go play it safe and hit 200 and be on the safe side. Alright, graph it. Oops, 200. Graph it. Right, there we go. Alright, now I can see. So there's the flight of the ball. I want to know what the maximum is, and, well, that's going to be my next question. But first I want to know which side of the maximum is my 4 seconds on. And so, based on here, it looks like it's on this side, but I'm going to check it out. I'm going to hit second trace, type in my value, 4, and it's on this side, right? When it's 4, my height is at 208, and so I mean it's moving down at that point. It's already past its peak, max, and now it's moving down. And so after 4 seconds, it's moving downward. Alright, so there's the first question. Now the maximum. Find the max. Maximum height and when it occurs. Well, that would be my vertex. And again, I'm going to do it on the calculator. Alright, so find that peak. So again, hit second trace, max, so 4. Make sure you go to the left. Enter. You don't have to go that far to the left, but my cursor makes it go fast or slow, just depending on what my computer feels like doing today. Alright, hit enter and then guess. Hit enter. Alright, so after, and again, it's the 3. In 3 seconds, it reaches a height of 144 feet. Alright, so again, it has a maximum height of 144 feet after 3 seconds. Which again means that makes sense. So you could use this to have answered the last question about moving downward. If I'm past my peak, I'm moving down, right? Because I'm moving down after that moment. If I'm before my peak, I'm increasing up to it, so I'm moving up. And so had it been 2 seconds, we'd still be moving up, because it's before 3 seconds. Since we're at 4 seconds, it's after my peak, so I'm moving down. I'm decreasing at that moment. Alright, the last question, C, determine the domain and range in context to the application. What that means in context is what makes sense. So remember, we're dealing with time for domain, so time is always positive, and we're dealing with a distance, right, height above the earth, which is also always positive. It can be 0, right, you can be on the ground, but you're always positive. Same thing with time. And so when I'm looking at this, if I go look at the picture, my domain and range I have to use my graph. So I started off on the ground, it went up, it hit its peak after 3 seconds, and then it came back down to the ground. So I need to find this 0 in order to get my domain. Was that 3 seconds? It had 144. I actually know my range already. My range goes from 0 to the maximum 144. So my range is 0 to 144. So I start at a height of 0 and max out at a height of 144 and then come back down to a height of 0. Alright, so it goes between 0 and 144. The time, though, we do start at 0, but in order to figure out what the end is when the flight of the ball comes back to the ground, I do have to go back to my calculator to figure that out. So I go back to my calculator and find the 0. So I hit second, calculate. I want the 0, so I pick 2. And then again, it'll ask me to the left. Make sure to the left my y values stay positive to the left. Good enough. And then to the right, go negative, and then good enough, hit enter twice. Alright, so it's at 6. The flight of the golf ball is 6 seconds long. So it takes it 6 seconds to be hit, to peak, come back down, and come back down to the earth. So the flight of the golf ball is 6 seconds. So the domain is a 6. 0 to 6 is the entire time the ball was in the air. Alright, the last one. Suppose the revenue is given in thousands of, so I gotta remember everything's in thousands of dollars when I write out my answer. To produce and sell DVD players. Alright, so we're producing and selling DVD players. The revenue function given by x times 40 minus 2x, where x is in thousands, so everything's in thousands. Now this is actually a common problem we do in calculus, business calculus. If you all know business calculus, you'll be doing something like this, but using calculus to solve it. Alright, A, find the revenue at 2 and interpret the outcome. So A is just finding R of 2, so plug 2 in. So it comes, but then the interpret part is important to remember everything's in thousands. Right. If they produce and sell 2,000 DVD players, the revenue generated will be $72,000, right? So again, units, always put units with your application. So when they sell 2,000 DVD players, they'll get a revenue of $72,000. That's what the units are. Part B. This is the part that in calculus, you'd be asked to use calculus to figure this out. We're going to use algebra to solve it. Alright, we know it's a quadratic. Now, it's a little hard in this form to tell if it's a quadratic, but it is. If you multiply through by the x term, you get 40x minus 2 times x squared, so it is a quadratic. It is opens down, and so the maximum is the vertex. So the vertex is the maximum. So if I want to find the maximum, I have to find the vertex. Alright, so we just want to know how many should they produce and sell to maximize revenue. And so I need the vertexes. This is what I'm going to do by hand since the numbers are fairly small. Alright, my x value is the opposite of b over 2a. You can solve it with the calculator. It's fine if you want to graph it and solve it. And so we're going to get my opposite of b, which would be negative 40 over 2 times negative 2. And so we'll get 10, right? Negative 40 divided by negative 4 comes out positive 10. So x is 10. Remember, 10,000 DVDs. The revenue generated when we get 10, we plug that back into the original. So go back up here and plug it in. Or you can plug it there, it's fine too. So when I plug 10 into my revenue equation, it comes out 200. But remember, 1,000, or this is also 1,000. Alright, so they get a maximum revenue of $200,000 if they sell 10,000 DVD players. So remember, it's in thousand. That's important, right? 200 versus 200,000 is a big difference, so it's important that you include the thousand. 10 DVD players versus 10,000 DVD players is a big difference. So like I said, this is actually a problem here. If you go on to Business Calc, I think it's 135 at ICC, they will do this particular problem using calculus, the same exact problem. Alright, so that finishes up this set of notes. The last thing is regression with quadratic types. Alright, that's the last thing from this section.